This is 8-1, identifying quadratic functions. So one thing you need to remember is that the word quadratic had to do with a degree of 2. So notice in this equation, instead of like a y equals mx plus b, now we have a y equals ax squared plus bx plus c. The ax squared plus bx plus c should look familiar because it's the trinomials that we've been working with. They result in a graph that looks like a parabola. A parabola is a U-shaped graph. It could be this way, it could be upside down. There's many ways that it could be, but it's a U-shaped graph like that, the curved graph. The highest or lowest point on the parabola is called the vertex. Basically like the very bottom or very top point. So in that case, I drew it in blue on the graph provided there. And there's a minimum and a maximum. So if the vertex opens, if the parabola opens up, it's going to contain a minimum. If the parabola opens down, then it's going to have a maximum, the top point. In order to see if something's quadratic or not from a table of values, if you remember, to see if it was linear, we had to see that it had a constant change in the x and y. Well, now what happens is we have a constant change in the x, so a constant increase or decrease in the x, and a constant in the second time we do it for the y. So it's constant in the second difference. So I'll show you what that means. So in example 1, we're looking at what the x values are increasing. These are all increasing by 1. Now the y values, if you notice, first it increases by 7, and then it increases by 1, then it increases by 1, and then it increases by 7. So then we go to the next one, from 7 to 1. Well, that's dropping 6. From 1 to 1 is 0, and from 1 to 7 is up 6. If this second column, the second time we did it, if those were all constant, then this would be it would be quadratic. But because it's not, this is not quadratic, because the second difference of the y, second difference of the y values is not constant. If you're given an equation, you're simply looking to see if we have an equation that can be written in the form of y equals ax squared plus bx plus c. This is a linear equation. It's y equals mx plus b. There's no x squared here. So for that reason, this is not quadratic. It's not a degree of 2. And can't be written in y equals ax squared plus bx plus c. In example C, we're given an equation again, so if we want to see if that could be written in y equals ax squared plus bx plus c. And I know it can be. In fact, the negative 10x squared would move to the other side as 10x squared. So even though the bx is 0 in this case, we still have everything that we need, so this is a yes, because we have y equals ax squared plus bx plus c. Okay, use a table of values to graph. Well, we did that with y equals mx plus b at first before we learned some shortcuts. So really we're just taking that negative 2 and we're plugging it into the equation. So negative 4, it's negative 2 like that, squared. Now we have to use PEMDAS. We have to do this exponent part first. I'll highlight it. We have to do that part first. Negative 2 times negative 2 is positive 4, times the negative 4 outside gives me negative 16. Then we plug in negative 1. So negative 4 times negative 1 squared. Well, negative 1 squared is 1 times negative 4 is negative 4. Plug in 0. You're going to get 0. Plug in 1. So negative 4 times 1 squared. Well, 1 squared is 1 times negative 4 is negative 4. So I'm using PEMDAS every time. Times 2 squared. Well, 2 squared is 4 times negative 4 is negative 16. So those are my ordered pairs, and I'm going to just graph what I can. So negative 2, negative 16, that's going to be way off the graph here, maybe somewhere around here. Negative 1, negative 4, 0, 0, 1, negative 4, and 2, negative 16, something like this. And it almost looks like a V there, but you have to make it, we know it's going to be a U because it's a parabola, because it's If you figured it out, the second difference of the y's is constant. So I know it's quadratic, plus it says it was quadratic. So it's going to make a parabola. So for example B, we're going to plug in our values again. So negative 2 squared is 4 plus 2 is 6. Negative 1 squared is 1 plus 2 is 3. 0 squared is 0 plus 2 is 2. 1 squared is 1 plus 2 is 3. 2 squared is 4 plus 2 is 6. And then I graph these. So negative 2, 6, negative 1, 3. 0, 2, and then 1, 3, and 2, 6. And again, it made a parabola, a U-shaped graph. This time it opened up. All right, next one, plug in the negative 2. Follow PEMDAS again, so I'm plugging in. I'll do one out for you so you can see it. So I'm doing the negative 2 squared first because of exponents coming first in PEMDAS, well, before multiplication. So negative 2 squared is 4 times negative 3 is negative 12 plus 1 is negative 11. Then plug in negative 1. Negative 1 squared is 1 times negative 3 is negative 3 plus 1 is negative 2. Plug in the 0, you end up with 1. Plug in the 1. 1 squared is 1 times negative 3 is negative 3 plus 1 is negative 2. And plug in the 2. 2 squared is 4 times negative 3 is negative 12 plus 1 is negative 11. And we graph this. We have negative 2, negative 11. It's going to be off the graph here. Negative 2, negative 11 is approximately there. Negative 1, negative 2. 0, 1. 1, negative 2, and 2, negative 11. So here's my parabola again. I missed the dots. Try to connect the dots. So when you write an equation into standard form, so y equals ax squared plus bx plus c, if the a is positive, the graph is going to open up. They're saying if the a is greater than 0, that would be any positive number, the graph's going to open up. If the a is negative, the graph's going to open down, so meaning if the a is less than 0. So we have to put it in standard form first. Like this right here, the y is not isolated. I need to move that. When I move it to the other side, opposite side is going to become the opposite sign. So I know it's going to be 1/3 x squared plus x minus 3. Really, I'm essentially adding 1/3 x squared to both sides. And there were no like terms, so I just rewrote it. But since a is positive here, it's greater than 0, I know that this graph is going to open up. Okay, and the next one, the y is already isolated, so when I look at my ax squared, even though it's not in standard form, I can see it's going to remain negative since the y is isolated. So since it's negative, this is going to open down. So since a is negative or a is less than 0, the parabola is going to open down. Okay, to find minimum or maximum, well, since this is sitting at the bottom of the graph, since it's a U-shaped graph, it's sitting at the bottom, we call that a minimum. And the minimum happens to be at wherever it hits on the y-axis, so it's at positive 2. And then we have to identify the vertex. Well, the vertex is written as an ordered pair, but it's just that bottom point. So as an ordered pair, it's going to be at 1, 2, 3, negative 3 on the x and 2 on the y. Okay, for the next one, the maximum, because it's up top, the maximum is at the number 5, and that ordered pair is going to be 2 on the x, 5 on the y. So 2, 5 for the vertex. Vertex is always an ordered pair. Minimum or maximum is just the number where it is. Think of it as like the height. Okay, remember that domain are our x values and range are our y values. So if you have a parabola that continuously opens up on and on forever, it's going to hit all of the y values because it's just getting wider and wider and wider. It's going on forever. So for that reason, our domain is always going to be all real numbers. So every time it asks the domain of the parabola, you're going to say the same thing every single time, all real numbers. Now the range is a little bit more tricky. You have to think about if it's a minimum or a maximum. So if you look at the range, all the y values are starting at that minimum and working its way up. So that's why it's going to be greater than in this one, greater than or equal to. It's always going to be equal to because it's a closed circle in this case. So it's greater than or equal to our minimum value, which was 1. Hitting at the 1 on the y. Okay, so in this graph, I'm looking at, this is counting by 1, so -1, -2, -3, a maximum of -3 at -3. And the vertex is going to be at -1, -2, -3, -4, -5, -5, -3. And for the domain and range, remember the domain's always going to be all real numbers. It's going to be everything. And now the y values, if you notice, the y values are all below that maximum point. So it's going to be less than or equal to, y is less than or equal to, and the number that the y was at, which was at -3.